Okay, video recording of lesson 5 titled Fields, Backing Fields, and Dependent Properties. But before we get into lesson 5, let's recap. So our developer diagram here, our developer tools diagram has slightly evolved. So I've added in the debugger here. We talked about in the lesson 3 exercise how to use the Visual Studio debugger to freeze our code at a certain point of execution and then execute lines of code line by line to help understand how it's working and be able to inspect how the data changes in our program. So check out lesson 3 exercise if you want a refresher on the debugger. And of course, we also talked about Git. So this was lesson 4 and our first homework assignment. We used the Visual Studio integration for Git to save these different versions of our code, right? And these versions are all stored in what Git calls commits. And then we pushed these different commits to Azure DevOps so that they were into the repo section on Azure DevOps so that they were available for the rest of the software development team. Okay, so this is where we are. We'll keep building this diagram as we progress. Okay, and so as we submitted our first homework assignments, we used Git and Azure DevOps to, for one, get practice at using these tools, and for two, give you this kind of code level feedback on your homework assignment. So here's an example of that code level feedback, right? Line 41. You did one thing, I suggest you do something else. You can take a lot of these suggestions with a grain of salt. A lot of times I'm just trying to share different language features or different ways of writing things just to help broaden your perspective on software development and writing code. So this comment is pretty completely inconsequential to the actual solution, and so I'm just trying to share that with you. And so the process we're trying to replicate here is the code review process. So software development teams, they may have a code review process in place where developers submit their code and other developers review that code and put comments like this on there to just kind of exchange knowledge, but also to increase code quality. So the idea being if someone's reviewing your code, then you're gonna prepare it so that it looks nice and that it's easy to understand for another reader, which is gonna lead to higher quality code that is more maintainable over time. So that's the process we're trying to replicate here. And of course, again, a lot of these comments should be taken with a grain of salt. And so that's kind of what this diagram is getting at here. It's really a hard thing to write code that is understandable and readable to other people and makes sense and all of those things, right? It's very hard to do that in practice. And so even good code has problems with it, okay? So just kind of want to fill you in on why we're submitting these assignments in this way. Okay, so before we get on to lesson 5, one more slide to show strategically where this course is going. So right now we're in this section of the course. We just finished module 1 and we're moving on to module 2 starting with lesson 5. And this first chunk of the course is intended to develop some technical building blocks that we're going to need to be able to build larger, more complex programs. So in particular, our technical building blocks in this course are objects and object-oriented programming. And we are using them because to write large, complex programs or pieces of software. You need to be able to break code down into smaller, more easily understandable units in order for you to build the thing correctly, right? It's too hard to reason about a really long program that's not broken up into some logical units. So our solution to that is objects and object-oriented programming in this course. So what you can expect in the first section of the course is that assignments will be pretty well structured and designed to make you practice using these objects and combining them. So that's what you can expect here. In the next part of the course, we'll talk about a variety of other tools and tricks and C# features. So we'll talk about link and extensions, which are some C# features that you probably haven't seen an equivalent to in Java or Python. We'll also talk about tools. So we'll talk about storyboards and app deployment tools and how those pertain to the software development process. Software testing tools we'll also talk about, and a variety of other things. But what you can expect in this part of the course is that assignments will have more of an open-ended component to them. So there'll still be some structured questions to kind of make you practice certain things that we're talking about, but an assignment will probably have at least one open-ended question where you'll have to, you'll have the freedom and the responsibility to explore something in the way you see fit. Okay. More about that when we get to this module. But after that, we'll be moving on to the final phase of the course, which the assignments will be, there's only one assignment, it's the final project, and it'll be almost entirely open-ended. So, the expectation is that you find a problem or an area you want to explore, and you write code to help you solve that problem or explore that area or something along those lines. So that's the final project, and content-wise, we can talk about whatever we want. So last year we talked about desktop applications and web APIs. This year we could also talk about those, but I'm also open to adding in other content if there's something someone's interested in. So kind of whatever helps you with your final project, we can talk about in this last module. To some degree, I don't know everything, so as long as it's something that I think I could teach. Okay, so starting out lesson 5 here, just want to refresh everyone's mind on classes and objects. So we talked about defining a class or a blueprint or a definition that tells you how an object works in general, or what data an object contains in general, right? So in general, cats have fur colors and breeds and claw lengths, and what they can do in general is speak, and when a cat speaks, they say meow, right? So that tells us what this object has and how it behaves in general. And then once we tell C# that, then we can start creating these cats and using them in our program. Okay, so that's just a refresher there. One small point here: whenever you have something that's numerical, right? So this is claw length, right? Numerical value. I would suggest always, I think it's the best practice to always put the unit on the end here. Okay, so claw length in inches. space probes have crashed because there was the wrong unit was assumed in software, right? So, true story about a Mars climate orbiter that was sending out measurements back to mission control, and the software on mission control was interpreting those measurements in the wrong unit. Right, so always good to keep your units on numerical values. So just a small point to make here on this refresher slide. And also structurally throughout this lesson, I'll tend to use these kind of simple objects, so cats and dogs, to explain things syntactically or structurally, and then we'll use kind of slightly more interesting examples to talk about why you might want to use one design over another. Okay. Okay, so one more refresher slide just to break down these classes in terms of the components we've talked about. So we've talked about constructors. So this is dog class. We talked about constructors. So this is how you, this is what ensures that your object is in a valid state when it's first created. And we also talked about how constructors can take in parameters as well if you need to provide some additional piece of data in order for your object to be ready to use when it's first created. Okay, we talked about properties, and we talked about methods here. Okay, small point on this slide. You'll see here for these properties, there's a get, but there's no set. We talked about private sets in the previous lesson, but here there's just no set. And when there's no set, that means the only time you can set a value for these properties are in the constructor. Okay, so breed, for example, breed is taken in by both constructors, and that's the only time that breed can have a value set. Okay, so that's what omitting the set keyword does. So now we introduce a new component to use when we're designing our classes, and that component is fields. And so the difference between fields and properties are similar, but important differences here. Properties, we said, are typically public and have this get set syntax here. And we saw that the setter could be private in case of the thermostat example, and we also just saw that it can be omitted entirely. Fields, on the other hand, are typically always going to be private, and because the whole thing is private, there's not that get set syntax or this getter setter syntax attached to them. So you can think about this getter setter syntax as a way to denote whether code outside the class can read or modify this property. But in fields, since fields are private, code outside the class can never read or modify these pieces of data. So you can think about these as like local variables to the class that can only be accessed from within the curly braces of whatever class you're in. So now, of course, from within this class, you can modify these however you see fit. So you can set the values of these fields through a constructor or through other methods, or you could have some method that makes a modification to one of these fields. So you can change them however you need to from within the class, but outside of the class has no knowledge of these fields. Okay, so let's talk about why you might want to use these. So here's our thermostat class again, and last time we saw that our goal temperature either had a max value of 80 and a min value of 60. And so that would be good for a house thermostat, but you can put thermostats in different places. You can put them on refrigerators and freezers and combustion engines. This could be thermostats in all sorts of places, and depending on the place, the minimum temperature and the maximum temperature might have a different valid range. Okay, so our minimum, so we take in minimum and maximum temperature in the constructor, and we use that, to set the min and max. Okay, so now, so from here, internally, this thermostat needs this data to be able to ensure it's in a valid state, but this information is only pertinent or important to the thermostat class itself. We don't want to make these accessible from outside of the class. And so if we were to make it accessible from outside the class, it might look something like this. So we make them public properties, and we still want that private set, but because we don't want people to be able to change these values willy-nilly. But, for example, you could make the get public so that code outside of this class can see what the minimum temperature and maximum temperature is. And so now the difference here, or why you might want to prefer the private field over the public property with a private set, right? This logically does the same thing, but and the reason is encapsulation. So generally, in object-oriented design, we want to hide as much about an object as possible. Okay, so the min temperature and the max temperature, no one cares about when they're using their home thermostat, right? For example, so if you have this, that you could think about your thermostat is telling you current temperature, goal temperature, and then you have this min and max. But no one who uses a home thermostat cares about the minimum or maximum temperature of their thermostat. And so using this kind of is reflective of that. We don't really care about what the min and max is, but we just want to ensure we store this information internally so that our thermostat doesn't go out of range. Okay, and so if you think about it like that, this is more complex from the user standpoint. From the user standpoint, your thermostat's saying more things, and you really don't need to know the min and max temperature because you're probably never going to run into those limits anyway. Okay. Additionally, in C#, there's these special kind of fields called backing fields. Okay, so backing fields is, it's still a private field, but this private field is going to work in conjunction with a public property to provide additional control. So, for example, we have two logically equivalent classes. They do the exact same thing, and people who are creating dogs are going to have the same pieces of data or same properties available to them, regardless of either of these implementations. So this is the simple one, and this one here, we're using private fields that store internally what the data is, but then we have these public properties that expose that data. Okay, so you can see here the property is name, but get, we have some more syntax attached to the get, and that's the instructions for returning or retrieving the name to the person or to the piece of code that asked for the value of the name property. So, okay, well, how do I get the value of the name property? Well, I want to look at the private field called name, underscore name, and return that value. And how do I change the name property on a dog, right? So the instructions for that are in this set. So in the set, we can say given, so value is kind of a magic keyword that's only used in these setters. And we can say whatever the value the calling code wanted to put in this name, we take that and we assign it to our name backing field. Okay, so again, these are logically equivalent classes and work exactly the same way, except we have these more syntax here where we've separated the public property from the private fields. Okay. So why use that? It was more code, but there's use cases for these, and that is when you're using this syntax, there is no control, right? It's you're given a name, you set that as the value of the property, or you want to read the name and you just take the value of the property, but what you can do now when you're using this additional syntax with the backing field is you can add additional logic that could do a number of things. So, for example, here's a derivative of the thermostat class, and in this derivative, we just set the temperature, right? So maybe there's no buttons. Maybe this is like a phone, like a smart thermostat, and you just enter 70 degrees, and then it sets your goal temperature to 70 degrees. And so that's kind of what we're emulating here with this class. And so we have that public property to set the goal temperature, right? We have a public get and a public set. But in the set, we want to perform this additional logic to ensure, the user doesn't enter 150 degrees, right? So we're able to add this logic in before we perform the set or before we change the backing field. So that's the advantage of this here. Is when you want this additional control, you can use the backing field method, and then you can add in your logic here in the set. So that's one example of why you might want to use this. So now, of course, this should be natural to anyone coming from Java. So in Java, the convention is you always follow this pattern. You always have private fields, and you make methods. So you could think about these get set things as a very special C# kind of method. And so in Java, you write the method yourself. So you have private fields, and you have the public method that returns the value of the private field. Or you have private fields, and you have a public set method or a setter method that takes in a value, and then, if necessary, performs additional checks on that value, and then eventually sets the backing field. Okay, so this is the Java convention. This isn't Java code, but it's the Java convention. And we'll avoid this in C#. We'll want to use this syntax here. But if I had to make an argument for why this is a good pattern, is that by default or by convention, you are saying everything about a class should be private, right? Everything, all the data that's associated with your class should all be private, and no other code from outside of this class should be able to see it. Okay, so that's what's happening when you're initially designing your object. Now, if you need to make the information accessible from outside the class, then you have to take another deliberate step of adding these public methods. Okay, so there's no shorthand, and from arguing from a Java perspective, it helps us kind of expose as little information as possible about our objects when we're designing them, and we have to opt in to getting and setting these private fields. Okay, in C#, we kind of have a little bit more of a practical shortcut where on its face about value, if you just want simple properties on an object, and you don't really care about these access modifiers and whether outside code or inside code can read and write them. We have it simple by default. Well, if you want that, then just write this. And if you need this additional code in the case of thermostats, then you can add that in. Don't write in this style though. Write in this style. Okay. So now another good reason for backing fields. So sometimes when you set a value, you might need something else to happen in that class. Okay, so this is a car class, and it has this public field for headlights on or off, right? Because code or actors outside of the car can toggle headlights on and off. And code outside or actors outside of the car class can change the current speed in miles per hour by pressing the gas pedal and so on. But now we need something else to happen, right? So if the current speed in miles per hour drops significantly, right, we need to deploy the airbags, right? So here we're not really constraining the value of the current speed, because if you hit a wall, your current speed is going to go way down, right? But if you hit a wall, we need something else to happen, so we can deploy the airbags. So that's another good reason for this backing field pattern, because you can add in whatever logic you need, in addition to setting the value of your property. Okay, one more thing to add here is this idea of dependent properties. So because we have this syntax where we can add in special instructions for getting a value or for setting a value, we can also make properties that are not dependent on any of these private fields. And so for example, the full name property, well, if the user asks, can you give me the value of the full name property for this student? Well, we don't need a backing field to store the full name, and we don't need full name to store any value either. We just want to provide instructions to say, well, if someone asks for the full name property, we just take the first name and the last name and combine them with a space. Okay, so we can add in instructions to derive new properties based on our existing properties, or new properties based on our existing fields. And they don't need to be the same type either. So for example, we have this property eligible for graduation, right? So this is a true or false Boolean value. And when outside code asks for the value of eligible for graduation, well, we write the instructions right here. And so we just look at the credit hours. If it's greater than a certain value, we return true. Otherwise, we return false. So you can write these properties that are dependent on other pieces of data in the class. Okay, so with that, we'll transition to an exercise. Okay, so for the lesson 5 exercise, we'll be doing a traditional object-oriented programming example here. So where you are going to model a bank account, and our bank account will have the following requirements. So to create a bank account, we need a social security number and an account holder name. We cannot create a bank account without these things. We should be able to read the account holder name. We should be able to see the last 4 digits of our social security number, but not the whole social security number. The account balance should be public. Account can be deposited to, and the account can be withdrawn from. If the withdrawal is greater than $500, the Social Security number needs to be confirmed. And if the withdrawal results in a negative balance, we seize all of the account holder's money, and we add $1,000 of debt to the account. Okay, it's quite an overdraft fee there. So now we have some starting code for this exercise. Okay, there it is. We have some starting code for this exercise so that we can focus on the design of the bank account class and not kind of all the other stuff. So we'll take this URL and we will go to Visual Studio. And by the way, this URL is just this clone button here. So I'm in an Azure DevOps repo. I click clone, I copy, and from that URL, paste it in. And I'm going to change the target folder here to users. I'm changing my target folder to software dev tools here. All right. Lesson 5 exercise. Okay, cloning the starting code here. Okay, so we cloned it, and here we go. So here it is. So we have a main program already chalked out, and this should do stuff we're all familiar with based on our completion of homework 1. But additionally, we have this helper class here, user input helpers. Okay, and so this will provide some ways to get input from the user and ensure it's valid. So, if we prompt the user for a string, we have a simple method here. But if we want a social security number, there's some validation to make sure they entered the social security number correctly or in a valid format. And it'll keep asking the user to try again until they enter something in a valid format. Same thing for integers, doubles. There's also this method that says, the user's got to enter one of a select set of options, and until they successfully enter an option that's in the set of options that are acceptable, we'll keep asking. Okay, so so these are just helper functions here, helper methods, and we use them here in this program. So let's go ahead and run the program. Okay, so welcome to Shark Capital Bank. Let's force you to set up an account, right? Account holder name, social security number. All right. Oh man. It's a good thing we have these validation methods here. There we go. Okay, so account has been established, and now you have 3 options: deposit, withdrawal, check balance. I guess 4 options, and then exit. So this is just user interface code. Right, so you enter these, and nothing's happening because the only thing that's defined or coded is the user interface. Okay. Okay. This didn't work. We got to do done equals true. Okay. All right, so now we want to focus on our bank account class. So we have the user interface set up to ask these questions and get the information we need, but let's design the class. Okay, so we want to add a new class. Okay, so I'm going to arrange, this is how I like to arrange it. So main program, and then the class we're using. I'm going to change this to public, and I'm going to add a constructor. By the way, a quick way to add a constructor with no parameters is to write CTOR and then tab, and then you get your constructor. Okay, so we see here, we're setting up the account. So according to our requirements documentation, to create a bank account, a social security number and an account holder name must be given. Okay, so a bank account cannot exist without those two things. So that should be a signal that we want to have a constructor that takes in that data to ensure when the bank account is created, it must be in a valid state. So let's do that. So we create our bank account instructor and we take in a account holder name and we take in a social security number. Okay. So now if we go back to the program, let's go ahead and create that bank account now. So bank account equals new bank account, and we pass in a name and a social security number. Okay, so this creates our object, our bank account. All right, and now let's right. So we haven't put this data anywhere. So this constructor's asking or requiring this data gets passed in, which we're doing. But now we need to put that data somewhere in our class. So let's look at the requirements documentation. So it's saying the account holder name should be public. Okay. Well, if that's the case, then we might as well just use a public property. Account holder name. Now, should we be able to change the account holder name? Maybe, maybe not. We'll say we can. People change their names, so we'll just leave this as a public property with public getting set, and account holder name equals account holder name, making this information public. Okay, and the other information we took in was social security number, and if we look at our requirements doc, we see the last four of the digits of the social security number should be public, but not the whole social security number. Okay, so what we're getting in, though, is the whole social security number. So for that, I think the best option is going to be a private field, social security number. Okay. And okay, so all we've done is we've taken in those two pieces of data, and we've written instructions for where to store it in an object. Okay. So now, first thing a user is going to be able to do is deposit. Okay. All right, hold on. Before we get there, the account balance should be public. Okay, account balance should be public. All right, so let's add that in. Public double balance. Okay, so it's public, so we got public get. Probably don't want a public set on that. We don't want people just changing their account balances to whatever they want. Okay, so we've added a balance property. All right, so let's before we do deposit, let's just do the check balance here, just so we can run the code and see that we've actually done something by setting up this class and object. So let's just do okay. So we do check balance, and nothing happens. So now let's code that. Okay, so we want council dot write line, and I'm going to use this syntax here. So if you put a $sign before your string, you can it provides a shorthand for concatenating strings with data that's in your variables. So balance for, and then to access that shorthand, you use these curly braces. Balance for account holder names account. Well, we can even do like an apostrophe s. Okay, so balance for this person's account is account dot balance. Okay, so let's terminate the program and run it again and see how this works differently now. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, account has been established. If we check balance now, yeah, there we go. Balance for this account is 0. Okay, so that seems to be working. Okay, so let's do the deposit. So account can be deposited to. So we might write the instructions for that with a method. So public void deposit, and can deposit some money, and we can add that money to the account balance. Okay. Right. So these are the instructions for depositing. Take in some money from the calling code, and add to the balance. Okay. So when we do deposit, we're going to need to ask the user a question. So how much money equals user input helpers dot prompt for double. How much would you like to deposit? Okay, and then we can do account dot deposit that amount of money. All right, let's run it. Okay. Check balance. Okay, balance is 0. If we do deposit, how much? It asks us how much. Let's put $100 in. Okay, if we check balance again, now when we check balance, it's saying the account has 100 in it. I don't like this spacing here though. I'm gonna change this a little bit. I'm gonna do the prompt like that. Okay. Okay. So that's deposit. That's check balance. Now withdrawn. The account can be withdrawn from. Okay. So we have some special rules here. So if a withdrawal is greater than $500, the Social Security number must be confirmed, and if the withdrawal results in a negative balance, we seize all of the account holders' money, if they have any, and add $1,000. Well, this bank sucks. And add $1,000 of debt to the account. Okay. All right. So withdraw. So first thing, so on our user interface portion, or the main program, we need to ask how much money goes double. Right, and so we have two variables with the same name, but because they're in different branches of the program, we can reuse that name. Okay, these are different variables because they're not in the same set of curly braces here. Okay. Okay. So let's just let's handle. Let's handle the second requirement first, okay? If it results in a negative balance, seize all the account holders' money, if they have any, and add $1,000 of debt to the account. Okay. So account, so we need to add a withdrawal method. Public double withdraw. Okay, and we got to take that. So I'm just gonna implement it without our exact requirement first, so we can get the main program working. So balance minus equals money, and then let's return that money to the user, however much they withdrew. Okay. The bank gives you. Oh, so hold on. Bank, I don't know, withdraw. Okay, so this is how much the user wants. This is the result. This is how much the bank gives the user after they ask for this much. And we'll write a little prompt like the bank gives you bank withdraw. Okay. All right, let's just test this this simple implementation first before we hit all the requirements. Okay, so account holder name 2, 3, 5, 6, 7, 8, 9. Okay. So we deposit 100. We can check balance. We have 100. Let's withdraw. How much would you like to withdraw? I don't know, 50. Bank gives you $50 back. Okay, good. So the simple version is working. And one thing I'm going to add here now is when we deposit and withdraw, I'm just gonna, I shouldn't copy paste this, but I'm gonna copy paste this here. Just seeing the current balance after we withdraw or deposit. And I'm actually gonna put a new line before that. So now let's get to the requirements here. So if a withdrawal results in a negative balance, seize all the account holder money. Okay, so wrong method. All right, withdraw. If balance minus the money they're seeking to withdraw is less than 0, then we seize all the money. So balance is now 0, and we add $1,000 of debt. So we subtract 1,000 from the balance. Okay, but now we got to think here. So if the balance was already negative, though, then we don't want to zero it out, right? Because then we're taking debt off the customer, right? So we want to say if the balance is positive, then we seize the money. If it's not positive, then we just, well, either way, whether it's positive or not positive, we add more debt to the account. Okay. So that's what happens if they overdraw. Otherwise, we just take the money out of the account and give it back. All right, now we're getting an error. Bank account withdraw, not all code paths return a value. So if you try to withdraw and you're in this branch, either you've overdrawn, then we just return 0. Okay. And here we go. So there's our withdrawal method. I believe it hits this requirement here. Okay. Let's see if it works. 3. So we'll deposit first. Deposit 100. Okay, account balance is 100. We'll withdraw. How much would you like to withdraw? Let's withdraw $102 here. Bank gives back $0, and the balance is now negative 100 or negative 1,000. All right, well that sounds like we hit it. So that's kind of a weird. Like if I was programming for this bank, well, I'd feel really guilty at programming for this bank. But say I was, we could put a comment here, like explaining why we're doing what we're doing. Capital Bank. Where we rip people off, right? All right, there you go. So now we have a little comment that kind of describes why we're doing this, right? We're doing it because of shady business practices. Yeah. Anyway. If a withdrawal is greater than $500, Social Security number must be confirmed. All right. So now we want to address that requirement. So let's start on the program end. So first we need to add some additional interface logic. It says confirmed Social Security number equals user input helpers dot prompt for Social Security number. I don't know what happened there. Okay. So confirm Social Security number. And what we're going to do is So when we make the withdrawal, well, hold on. This is in the wrong order. Okay, so first we ask how much they'd like to withdraw. And if they would like to withdraw more than $500, then we're also going to need to ask this question. If they want less than $500, we can make the withdrawal here. Okay. So now what do we do here? We got double bank withdraw equals account withdraw. Now we need to check the Social Security number with when we withdraw. Okay, and the only part of the only part of the program that has the established Social Security number is the account, is the bank account. So we need to pass in two things here. So we need to pass in the money, the amount of money they want to withdraw, and the confirmed Social Security number. So now we have two methods here, and we're getting some errors popping up. So I guess let's deal with this one first. So we have this withdraw method, and we only have a withdrawal method that takes in one parameter here. But we can also add another withdrawal method, public double withdraw, and they can have the same name, but they have to have a different set of parameters. Double money string social. Okay, and so we'll have to implement this withdrawal where so I'm just going to return 0 just for now. We'll have to implement this, but let's hop back over here and look at this. Okay, so money. How much money? Okay, so let's look at this. So we're getting this error. Bank withdrawal does not exist in the current context. And I think it's right because bank withdrawal is, the scope of it is the if statement here. So it's not available outside the if statement. So we could pick this up and paste it in both, but now we're doing the same thing in either case. So I broke something here. We're doing the same thing in either case, so we probably don't want to duplicate this code. So what we can do instead, I'm going to undo this. What we can do instead is leave it down here, but we can initialize the amount being withdrawn outside, right? So we can say there will be a variable called bank withdraw, okay? That's available in this outer else if statement. And we can say we'll ensure the value of bank withdraw is set by the time we reach the code that wants it, right? And so that's with this if else. One of these is going to be true. Either the if will be true or the else will be true. And so by the time we get down here, we will ensure that bank withdrawal will be initialized with the value. So it saves us from duplicating that code. All right. Now let's think about this. So we have two withdrawals. One of them requires a Social Security number, and the other doesn't. So we got to think about this now. So what happens if we call this withdrawal, but the amount of money that's being asked for is greater than $500. We don't want to let that happen. You cannot call this withdrawal if the amount of money is greater than $500. So what we want to do is, if you have to call the other withdrawal. If money is greater than $500, then we're just gonna return 0, right? You're not supposed to use this one. You're supposed to use the other one, all right? And so now with this one, we need to confirm the Social Security number. So if Social Security number doesn't equal the Social Security number we have on file, then we're just going to give them back 0. We don't want to do anything. Okay, just give them back $0. All right, they didn't correctly confirm their Social Security number. Now here's the pivotal point here, is that we could copy all of this code, right? This should work, right? But we don't really want to do that, right? Because then we're duplicating our weird Shark Capital Bank policy, overdraw policy. So, say the government regulates this bank, saying you can't have overdraft fees that are this absurd. Okay, we don't want to have to change our overdraft policy in both methods. Okay, so we really want to make sure this weird overdraft policy is only in one place. So if we have to change it, we only have to change one area of code. So I'm going to undo this paste, and what we're going to do now is I'm going to make another method, but it's going to be private, and I'm going to call it internal withdraw. Okay, so this is not, you cannot call internal withdraw from out here. So double money, right? And I put this logic here. All right, hold on. Return, right? Just to visualize that real quick. So there, if I go account dot, there is no internal withdrawal because it's private. Okay. So this executes our special overdraft policy, and both of these withdrawals are going to want to use that functionality. So in this case, we check that the value is under 500, and if it is, we return the result of internal withdraw. So if it is, we jump to this code and we execute our overdraft policy. Okay, now in this code, we check to make sure Social Security is correct. If it's incorrect, we return 0. Otherwise, whoa, hold on, I screwed this up. Come on, else we return the result of internal withdrawal. All right, and that should take care of it. So let's run this. Okay. Okay. Let's deposit 1,000. All right, and let's try to withdraw. So let's try to withdraw 750. All right, we have to confirm the Social Security number. So let's enter the wrong one first. All right. So bank gives you $0 back, and our balance is still maintained at 1,000. And now let's try this again. 750, and confirm the Social Security number. Okay, bank gives 750 back. dollars back, and the withdraw is still, or the result, our resulting balance is 250. Okay. Let's do it again. Let's withdraw another 750. Confirm the Social Security number. Now we can see bank gives us $0 back, and the balance is negative 1,000. Okay. And so that's our deposit and withdraw method. Now there's one thing I forgot. The last four of the Social Security number should be public. Okay, so let's implement that. So we need to expose part of our Social Security number. So for that, now we're already storing the Social Security number in this field. So for that, I think a dependent property is going to be what we want to use. So last four of social. And what are the instructions for getting the last four of the social? Well, we want to return Social Security number, yeah, something like this, right? We want to return the Social Security number, and we want to probably use some kind of substring method here. Hold on, I'm missing a. So we could use substring to get the last four, but I don't really want to reason about indexes, so I'm going to do something a little bit different. I'm going to reverse the Social Security number. I'm going to take the last four, now it's the first four. So we reversed it. I want to take the first four, and then I want to reverse that. All right, so it's just a little bit different way to do this. And I might have to do toList at the end. Maybe I need to do toString at the end. Okay, yeah, that's it. So just a little bit different, just to show you, like, you don't have to reason about those indexes if you don't want. You could perform this kind of interesting manipulation going on here, where we reverse, take four, reverse, and then return that. Okay, so let's see if that works. So now let's update our check balance here. Balance for this person's account ending in account dot last four social. Okay, so and I shouldn't be copy pasting this code, but I'm going to, just for okay. So let's see if that worked. Okay, we deposit. Oh, that sure did not work. Balance for account ending in system.link.enumerable.reverseiterator.systemchar is 100. Well, that did not go as planned. So why didn't that work? So system link enumerable reverse iterator. All right, don't worry too much about what I'm doing. You could just use the substring method. Probably easier. But now it's become a personal matter to me here. So I'm gonna be adding this weird stuff in here. Don't worry about any of this. All right, let me see if that works. If this doesn't work, I'll just suck it up and use a two-string or the substring method. I'll just check balance right away. All right, yeah, whatever. Okay. I suppose the start index would be 0, 1, 2, 3, 4, 5, 6. It'd be 7, I think. Try that out. All right, yeah, there you go. Perhaps it was easier to just count in my head what the correct index would be. But anyway. So there you go. That's the demo or the exercise showing kind of showing off these different things we talked about. Our private fields, our dependent properties, and so on. So that's it.